Welcome back to Robbie's Office Hours. Today we're talking about solving first order separable ODEs. It's a mouthful, okay? A lot of people will say, like, how do you solve these? Like, well, separate variables. They're separable differential equations. It's like, well, okay, great, like that, but why? Like, why does that work, okay? At the end of the day, yes, you're correct, separate your variables, integrate, do all this stuff, but why does that actually work? And it all boils down to what is a differential? Okay, so how do we understand differentials? So if I give you that y, okay, is y depends on x, okay? Depends on x. So x is my independent variable, y is my dependent variable, all right? Now if I want to say what the differential of y is, what is dy in this case? Okay, well how do I compute it? Well, if I know like a formula for y, for example, so if like y is equal to like sine of x or something like that, the first thing I do is I just multiply I find the derivative of y with respect to x, and then I hit it with dx on the right-hand side, okay? So as kind of a silly example, like I said, if y is equal to sine of x, and I say, what's the differential of y? Well, then I'd say dy is, okay, what's the derivative of sine? That's cosine, and then I just put a dx on the back end of that, okay? And people like to think about these as like fractions, which is total nonsense. Okay, like dy dx, they're like, oh, if I multiply by dx, it's a fraction, and the dx cancels the dx, and it's just no, absolutely not. No, okay, that's not what's going on. Okay, just yeah, don't do that. If it helps you remember, great, that's fantastic. But like, no, that's no. All right, so if y is equal to sine of x, dy is equal to cosine x dx. All right, so how do I solve a separable differential equation, okay? Well, remember, differential equations that are separable, first order, okay, they look something like this. dy dx is equal to some function of x times a function of y. Okay, remember that has to be the product of a function of one variable and the function of the other. Okay, so a lot of times people say like, quote, separate variables. And what they mean is like, get all your y's and dy's on one side and get all your x's and dx's on the other. Yes and no, okay? What I'm going to do is the following. I'm going to divide by g of y, but I'm going to leave dy dx here, okay? So what am I going to have? I have a 1 over g of y, dy dx is equal to f of x, okay? And then what I'm simply going to do is, look, if y depends on x, okay, then g of y will also depend on x, because g of y depends on y, and y depends on x, okay? dy dx will be something involving x, okay, because y depends on x, and the right-hand side is just a function of x. So it makes sense to integrate both sides with respect to x, okay? So now I'm going to say integrate 1 over g of y, dy dx, with respect to x, and that'll be the integral of f of x with respect to x. Okay? So now watch this very closely. What is dy dx times dx in that case? Well, that's precisely what the differential is. It's exactly what the differential is. So what I can do is I can replace this boxed term right here with simply a dy. Okay, so let me rewrite this whole thing. So this will be the integral of 1 over g of y dy. Now this freaks people out because they're like, that doesn't make any sense. You're integrating with respect to y on the left and you're integrating with respect to x on the right. That doesn't seem balanced, right? Like whatever you do to one side of the equation, you gotta do the other side of the equation. And it's like, I'm using the fact that originally on the left-hand side, it looked like this. We did integrate with respect to x. We're just using the fact that dy dx times dx is the differential of y. Okay? So let's see this in action. Okay, let's see how this works. All right, so if I'm given this differential equation, first order, separable, okay, nonlinear, notice because I have a y squared, dy dx is equal to xy squared, okay, and I want to solve for it. Okay, well, what did I do over here? I took the y term and I just divided it over. Okay, so I'm going to do the same thing. I'm going to divide the y over. So I'm going to get y to the minus 2 dy dx is equal to x, all right? And then what did I do? I integrated both sides with respect to x. So if I integrate with respect to x, I'm going to get y to the minus 2 dy dx is equal to the integral of x dx. Okay. And then we use the fact that this is just dy. So this really becomes the integral of y to the minus 2 dy is equal to the integral of x dx. Okay? Notice, what did we really do? If we want to break math, okay, and we want to think about this as a fraction, which it's not, but we want to think about this as a fraction, what did I literally do? It's kind of like I just moved the dx over, I moved the y squared over, and so I got something like y squared dy is equal to x dx, and I just said, integrate both sides. After all, that's where I ended up. Okay? If you like thinking about it this way, more power to you. It's a little mathematically sketch in a lot of ways, but it's fine, okay? Like, it'll get you far in math, okay? You're good. All right, but the question still remains, how do we solve this? Well, this is just straight up integration. So what's an antiderivative for this? Add 1, divide by it, so I get minus 1 over y is equal to add 1, divide by it, x squared over 2. Don't forget the constant. People often freak out. They're like, wait, this is an indefinite integral, so you should have a constant. This is an indefinite integral, so you should have a constant. And it's like, yes, in some ways. But look, if I had this as like minus 1 over y plus like constant 1 equals x squared over 2 plus constant 2, it's like just subtract that over for goodness sakes and call c2 minus c1 equal to c1 constant and save yourself the trouble, okay? And then from here, we could solve for y if we wanted to, multiply by -1, invert everything, do all the stuff, that's fine. I'm going to leave it right here because all I'm really interested in is illustrating the principle for solving first order separable ODEs. All right, so as always, like, subscribe, comment down below, let me know what you like in terms of the content and any questions that you have for me. Share it with your friends, but we'll just keep it going.